Welcome to the world of heat treatment. Welcome to our video on the fascinating process of heat treatment of steel. Now, you might be thinking, heat treatment? That sounds kind of boring. But trust me, this is way cooler than it sounds. We're talking about taking ordinary steel and turning it into something extraordinary. Something that can build skyscrapers, craft surgical tools, or even send rockets into space. Today, we'll uncover 10 key facts that explain why this process is so important in industries worldwide. From understanding the basic principles to exploring cutting-edge innovations, we'll delve into the heart of heat treatment and see how it transforms this ubiquitous material into a marvel of engineering. Get ready to have your mind blown by the power of heat. Let's dive in. The basics of heat treatment. So, what exactly is heat treatment? In the simplest terms, it's like sending your steel to a spa. We subject it to controlled heating and cooling cycles, almost like giving it a specialized sauna and ice bath treatment. But instead of relaxation, these temperature swings cause incredible transformations at the molecular level. See, the way those iron atoms are arranged, how close they are, how they're bound. Those tiny details determine whether the steel is strong or weak, brittle or flexible. With heat treatment, we can manipulate those microstructures, essentially rewriting the properties of the steel to fit a specific purpose. Think of a blacksmith hammering a sword. The heat makes the metal more malleable, easier to shape. Then, quenching it in water rapidly cools and hardens the blade, giving it that deadly edge. That's heat treatment in action, folks. It's ancient knowledge, but it's also at the forefront of modern manufacturing. The annealing process. Let's start with annealing, the chill pill of heat treatment. Imagine you've been working your steel too hard, bending and shaping it. It's gotten all stressed out, kind of brittle. Annealing is like hitting the reset button. We heat the steel to a specific temperature, hold it there for a while, like a nice long soak in a hot tub, and then let it cool down very, very slowly. This process softens the steel, making it more ductile, which is a fancy way of saying it can be stretched and shaped without cracking. Why is this important? Well, if you're trying to create intricate parts or you need to machine the steel into a specific form, you don't want it cracking or shattering. Annealing ensures that the steel is ready to be worked, like a lump of clay in a sculptor's hands. Normalizing steel. Now, if annealing is the chill pill, then normalizing is like a brisk jog around the block. It's still a heat treatment, but it's all about achieving a balance of strength and toughness. We heat the steel to a higher temperature than annealing and then let it cool down in still air. This process helps to refine the grain structure, which is like organizing all those tiny iron atoms into a more uniform and efficient arrangement. The result? Steel that's not too hard, not too soft, but just right. Think of tools, gears, or axles. These components need to be strong enough to withstand stress, but also tough enough to resist impacts and vibrations. That's where normalizing comes in. Hardening steel. Now let's crank up the heat. Hardening is where things get really interesting. This is how we make steel incredibly strong, able to withstand immense pressure and resist wear and tear. We heat the steel to an even higher temperature than normalizing, pushing it into a specific phase where its structure is primed for transformation. Then we hit it with a rapid cool down, usually by quenching it in water or oil. This sudden change in temperature locks those iron atoms into a super strong crystal structure called martensite. It's like taking a snapshot of the steel in its most energized state, freezing those atoms in a tight, rigid formation. The result? Steel that's incredibly hard but also more brittle. Tempering steel hardening makes steel incredibly strong, yes, but remember how I said it also makes it more brittle? That's where tempering comes in. It's all about finding the sweet spot, the perfect balance between hardness and toughness. Think of it this way. A hardened steel sword might be able to hold a super sharp edge, but it could also shatter like glass if you hit something too hard. Tempering helps to alleviate that brittleness. We take the hardened steel and heat it up again, but this time to a much lower temperature. This allows some of those tightly packed atoms to relax a little, relieving internal stresses and increasing the steel's toughness. It's like giving that hardened steel a little bit of give, making it less likely to crack under pressure. Quenching methods. Now, let's talk about quenching, that rapid cool-down step that's crucial for hardening steel. It's not just about dunking hot metal into any liquid, there's a whole science to it. The speed of cooling is critical, and different quenching mediums like water, oil, and even air will produce different results. Water is like a cold shock, causing the steel to cool incredibly fast and creating a very hard but brittle structure. Oil is a bit more gentle, like a cool bath, producing a slightly less hard but tougher steel. And then there's air, the slowest of the bunch, often used for components that need to be strong but not overly brittle. Choosing the right quenching method depends on the desired properties of the steel and the specific application it's intended for. It's about finding that perfect balance between hardness and toughness. Case hardening. What if you want the best of both worlds? A steel component that has a super hard surface to resist wear and tear, but also a tough core to handle impacts. Well, that's where case hardening comes in. This process is all about selectively hardening the outer layer of the steel while leaving the core softer and more ductile. It's kind of like giving your steel a suit of armor, you know? There are different methods of case hardening, but one common approach is to introduce carbon into the surface of the steel at high temperatures. This carbon diffusion creates a hard case on the outside, while the core remains relatively unaffected. The result? Components like gears, shafts, and bearings that can withstand both wear and impact, making them ideal for demanding applications. Stress-relieving steel can get all stressed out too, especially after going through processes like welding, machining, or forming. These operations can create internal stresses that might lead to warping, cracking, or even premature failure. Stress relieving is like sending your steel to a yoga class. It's a low-temperature heat treatment that helps to relax those internal stresses without significantly affecting the overall hardness or strength of the steel. We heat the steel to a specific temperature, hold it there for a while to let those stresses dissipate, and then slowly cool it down. It's like giving the steel a chance to breathe and find its equilibrium again. Applications of heat-treated steel. Now, let's talk about why heat treatment is so awesome. Its incredible range of applications. We're talking about everything from the tools we use every day to the most advanced technologies on the planet. Need a strong, durable wrench that won't round off those stubborn bolts? Heat-treated steel. How about a surgical scalpel that's sharp enough to make precise incisions? Heat-treated steel. What about the massive gears that drive wind turbines or the axles that support heavy-duty trucks? You guessed it, heat-treated steel. From construction and manufacturing to aerospace and automotive, heat-treated steel is everywhere. It's the unsung hero of the material world, quietly making our lives safer, easier, and more efficient. Innovations in heat treatment. Heat treatment has been around for centuries, but that doesn't mean it's stuck in the past. Like any good technology, it's constantly evolving and improving, with new innovations emerging all the time. We're talking about things like computer-controlled furnaces that can precisely control heating and cooling cycles, advanced quenching systems that optimize the cooling process, and even new surface hardening techniques that can create even tougher and more wear-resistant coatings. And then there are the materials themselves. Metallurgists are constantly developing new steel alloys with improved properties, pushing the boundaries of what's possible with heat treatment. Outro. Keep learning. Thanks for watching. We hope you found these insights into the heat treatment of steel both educational and engaging. It's amazing to think that something as seemingly simple as heating and cooling metal can have such a profound impact on its properties and applications. From ancient blacksmiths to modern engineers, Our ability to manipulate steel through heat treatment has shaped our world in countless ways. And as technology continues to advance, who knows what incredible new possibilities will emerge from this fascinating field. Don't forget to like, share, and subscribe for more informative content. And be sure to let us know in the comments what other material science marvels you'd like us to explore. Until next time, keep on learning.